tsunami that's with scientists yes मेरा नाम लिखा थी ना मेरा नाम नहीं लिखा
Good afternoon, everyone. Many thanks for being here, for your attendance. My name is Hussam. I have already double appointments between Egypt and USA. Actually, I'm serving as a professor of climate or applied climate in University, University in Egypt. At the same time, researcher and program manager. I cannot say that a smart climate program manager because someone who don't believe in a smart climate or don't believe in climate change, someone who believes that maybe the climate's constants not changed or okay. Anyway, it was supposed that I will show you the emissions trend from selected small ruminant farm in central Alabama. And I give you some proposed solution and to improve the livestock productivity. It's actually part of our project since USDA has awarded the university's grant. We survey for small producers and farmers in surrounding Alabama, multiple services like private farm experience, experiments, technical assistance, and a lot of service here. The strategy for the emission attempt, the emission trend for our strategy in our program, our project. The first thing we try to the real situation of the greenhouse gas come from the soil and as well from the animal as well, and the second second step here for mitigating the greenhouse gases from the soil and as well mitigating the greenhouse gases from the animals. This is our second experiment. And our solution here to using biochar injection in the soil and developing new forages. On the other hand, for the animals, we utilizing new techniques and also feeding the animals with biochar. For real-time monitoring enteric methane, we use some devices like laser methane detector and green feed. This is our second experiment. Since I am restricted with 12 minutes, so if you don't mind, I will jump about 40 slides. I will be focusing on the third experiment for us. Okay, so. Yes, this is our third experiment. We diagnosed the accuracy of using the laser methane detector with the green feed on farm measurements for enteric methane emissions from goat. I think the main motivate for me for that is from economic perspective. We have two devices here. To measuring this enteric methane, but the first of all, why real-time monitoring the enteric methane is important. The first, it's like represent as a 28% of for climate change, so it's very big amount, and the accurate measurement for methane production in ruminants is vital to develop accurate greenhouse gases inventories and give us like evaluate mitigation strategy. As you know, better than me, that there's a lot of devices collect the data and measure the enteric methane. Well, we have a lot of this, but in our lab, we're focusing on laser methane detector and the green feed system. This is what we conduct in our experiment. The first one, the green feed passage system that captured and analyzed the gases from the animals. When the animals are attracted to green feed with using like very good sound or the sound of the droplets of the feed itself. So they come and feeding. In that time, we which generate gas analysis. So in this time, we collect this data, and we have this is our unit in Tuskegee University. We know that laser methane detector it's usually using to measuring the gas leak from factories, from the economic or from the factories. But since 2009, a laser methane detector has been used to measure the methane concentration in the breath of the cattle, sheep, and goats. So we use this techniques. This is the device we have. This is our experiment in Tuskegee University, and we used all of this in our about 14 small farmers and producers involved in our project. We have all of this. This is the farmers we have, and as you see, like scattered around in South Alabama, and it's very harsh to me to drive this like trailers to go to all of these farms using the green feed system. It's bad headache for me. So at that time, I'm thinking to instead of towing the green feed system to all of these farms, I can use this mobile. It's very small, very cheap. This is the green feed is about $150,000. For this device, it's about $1,500. So it's the main motivation for me for that is economic perspective. So actually in that time and also there is another reason for that. Sometimes we settle our green feed system in any farm or small producers. You got unknown data like this. You got unknown data. So you ask yourself why I got unknown data for that. So because there is like some of big animals preventing the sheep and goat to attract to feeding from the green feed. So in that time you have to be there and collect your data directly. If you let your green feed system and for 1 or 2 or 3 weeks or one month, you will got some unknown data like this. So this is some reasons to motivate me to do this experiment. This is the objective of this experiment: evaluate diagnostic accuracy of laser methane detector compared to green feed system and determine whether laser methane detector can replace the complement green feed system or not. So this is the methodology of us, and also this is the program we used. We depend on R programming and some packaging from R. This is our hypothesis. Our experiment hypothesis, the green feed pasture system and laser methane detector corresponding enteric methane measurement, we used on the same group of Spanish per goat, the same location and the same environmental conditions during the same time period with the same diet. Based on the green feed system, a prediction equation, we convert because the unit is different. We converted the results to be in the same unit. And for the study design, we evaluated agreement between laser methane detector and the green feed. The green feed is a reference for us using 2 complementary analysis analytic frames, continuous agreement, and diagnostic accuracy for that. And diagnostic accuracy in our experiment refers to the ability of the test of accurately classify laser methane detector measurements as valid by comparing this result to the green feed system results. We will use some terms like sensitivity, and we refer that it's the percentage of positive correlation between laser methane detector and the green feed, specifically the percentage of negative correlation between laser methane detector results and the green feed results. For our results, we can see that no relationship. We found that no relationship between laser methane detector and the green feed. The regression line is almost flat. As you see, it's almost flat. Laser methane detector reading stay in narrow band around 6 and 7, while green feed up to like more than 18 in the time. So it's very, very big, wide range. We also did this a planned ultimate comparison between this methane detector and green feed. We found that it's the standard deviation it's more than 8. It's around 9. That's wide and not acceptable between green methane detector and green feed. The plot shows more negative difference at height average between both. And for the accuracy, it's about 48, and sensitivity it's very low, 34. For specificity, it's about 68 or 67, and for positive predicted values, it's about 60, and negative predicted value, it's about 41. So balanced accuracy, it's about 50. So we can conclude that no agreement beyond chance. And also for the receiver operating characteristics curve and its associated above curve under curve are a standard tool to use the measurement for this model, and we found that the area under curve indicated poor ability for laser methane detector to separate green feed positive from negative. Laser methane detector not replace green feed without any recalibration and some very strong calibration. And also the laser methane detector diagnostic performance against green feed is insufficient for standalone use the current 3.4. So sensitivity is about as I told you 35. So laser methane detector method is not suitable for diagnostic use. So our conclusion, laser methane detector have advantage like high accuracy, fast response, cheap, and it's very easy to use, and has a wide range of wavelengths, and also still one of fully qualified in genetic evaluation of animals regarding methane, unless further research is carried out to improve its repeatability. Laser methane detector can be useful for rapid screening, just rapid screening tool if data is carefully collected and analyzed. Laser methane detector cannot replace green feed for methane quantification without any improvement. I done this research, but there is no relationship between both, and we cannot use this. But if I go back for the standard deviation here, results for the standard deviation, when I said that the standard deviation here difference it's about maybe 9. If I add this 9 to the results of laser methane detector, it will be identical with the green feed system. So this is interesting, maybe result. So we can replace laser methane detector with the green feed, but if we add this as a constant, I think we can go, do maybe more accurate experiment. Thank you so much for listening. Thank you.
I think we have 1 minute for a question if there's a good one in the audience.